Hey guys. Okay. We'll start at this point. And yeah, really quick jumping into our subject. Today our subject is geotechnical engineering, and geotechnical engineering is like I don't know. You all knew this guy, RGV. He's one director in India. There are two kinds of people who there are only two kinds of people who like whenever they heard name RGV, one they like to the core, and they hate the other guys who hate him to the core. So geotechnical is the subject. There are only two types of people, one who loves to the core or one who hates to the core. Personally I believe, but as you are in my class, I believe after completing this session, you are one of amongst those who love this subject to the core. Why? Because it was like, if you think it in practical applications, it is very easy, and there is no such kind of thing you need to know great mathematics equations and all, or else you just require iterations and all. It's just need some sort of concentration to understand certain things, and the way you approach the subject defines how you are feeling with that subject. Okay, so fortunately, when you are studying your bachelor's or in master's, if you take up this subject, you may feel it is very difficult to understand the formulas, how they derive these formulas, how where these are very useful, or how to use these formulas to find out the answers. These are all the maybe few reasons you may not felt comfortable with this subject. But believe me, for FE, Geotech is the subject. It will give you the maximum amount of marks in part two, especially. So, Geotech generally comes in part two. So, in that part two, you may expect 10 to 15 marks. So, minimum marks you can get is 10%. Most of the times, it may come up like 11, 12 questions. So, 10% for a subject is a huge weightage. So I recommend, don't write off this subject, or don't leave this subject without just going through it also. So don't consider it is this is your weak area and you don't want to study, because in your bachelor's days you may encounter like hundreds of formulae, but for FE, it's all formulas in your handbook. It is readily available. There are few like 5 to 6 formulas you need to remember to cope up with this subject, and then you just need to understand by some questions, like if I can say like 6 to 7 questions are really easy peasy in this subject. By looking at the questions, you may cut down one or two options directly without looking at the formula itself. So the probability of getting right answer here is 50%, or else 33 to 50% always, even if you don't know about the what which topic it's specifically asking. But if you have certain amount of knowledge or background about what in which topic he is asking, you may get the chance of or probability of getting the right answer is 50 to 33% to 50%. So you may rule off two options very easily in geotech. So, and here is the syllabus of the geotechnical engineering. There are 11 topics. Out of 11 topics, I can say you can expect one or two questions from index property and soil classification, one or two, I can say two questions easily, 2 to 3 questions easily from phase relations and laboratory, I'm sorry, field test. Total and effective stress, you can get one question to two questions. And retaining of structures, you may expect one to two. And shear strength, you may expect one. Definitely, you're gonna see one question. And bearing capacity, you're gonna see one question. Or it was like based on bearing capacity and foundation type, you may expect two questions, but most of the time it was from one to two questions from bearing capacity itself. So foundation type is not a subject topic which is very much broad or wide or deeper than the topics which we discussed above. It was like just knowing the surface. So foundation type, you may or may not get one question. But here, for consolidation, this topic you may get two to three questions easily. And slope stability, uh, like from past 6 months, I think they are giving one question, one question. And slope stability, you may expect 0 to 1. It may not become to you. So looking at this, you may understood. So every topic in this subject is very important, and every other topic carrying each like 1 or 2 marks is good. That if you don't understand one topic, or you may not feel confident in one topic, you may get mark from another topic too. But I will say, don't leave first four topics and bearing capacity, consolidation of and ninth one, consolidation and differential settlement. Because if you understand these concepts, it is very much evident, you can easily get, even if you are not 100% confident, you may eventually get marks from the remaining topics. So that's the magic of this subject. And I believe you will get maximum number of marks in this topic, just following some tips, tricks, and identifying the correct options by eliminating some of the unnecessary options, which was generally a playing trick by the FE board for the Geotech especially. So these are the breakdown of marks and your syllabus too. So anyone have any questions until right now, or we just jump into the next topic?
Hello, sir. Sir, I have a real quick question.
Yeah, Mohammed.
Like, it's not technical. Like, I want to know if I can have the same video tomorrow morning, like while practicing, recorded one.
Yeah, maybe I I don't think they are like uploading it very late. Last time when I spoke to my the team, they said it was like they are taking only 5 6 hours to upload the video into your application. So you can expect the video tomorrow morning.
Okay, sir. And one more question, uh, like, how can I have the questions for practicing by tomorrow? Like, if I want to practice, how should I approach the practice?
That will be we gonna talk that of end of our
Like,
session. Okay.
okay, sir. Sorry, sir. Okay. Yep. Thank you, sir.
So yeah, okay, ma'am, no problem. So can anyone tell me or guess? I'm just not asking you to make the right answer. Just guess what are the soils. Can you name these soils? Whatever you are seeing in your screen. Anyone can please name those soils?
Silicon
The
clay,
Clay, silt,
Yeah.
black
black
cotton
soil.
soil,
Okay, this one black cotton soil.
the
uh,
red rock,
red clay,
Red or alluvial, right? Yeah, clay. Yeah, obviously some kind of sand, some kind of muram or sand, something, right?
Clay soils.
Yeah. So, how you told these are the this type of soil is this type of soil is this?
By their appearance,
Yeah,
categorized by
just by looking
appearance.
at just by looking at those by physical appearance, by the color, you end up guessing some of the soils was like that. Okay, so but in real time when you are going to your field or in your job, or you may see the samples of your soil, it was not evident that mm, every other sample or every other thing you get is pure black cotton soil or pure clay soil or pure sandy soil kind of thing. They are mixtures of soil. So you can see up to one layer it may be sandy. After that you may encounter some gravel sand, like thinner sands, and after that you may encounter some black cotton soil or something like that. So, or in nature, because if you are going to a site, you may experience there are two three kinds of mixtures of soil. So there is some amount of clay, some amount of silt, some amount of sands, and mostly pebbles, some kind of coarse soil. So we need to differentiate soils, and we need to identify the soil. Which soil is this actually? Which soil is this means we are saying this soil sample or soil we took, or the area which we are interested to find what type of soil is in that soil, the most maximum amount of constituent is clay, or maximum amount of constituent is sand, or maximum amount of constituent is gravel, something kind like that. So we need to differentiate these, and we need to identify those characteristics also. So why we need to identify the characteristics? So if I want to build a house in some sandy soil, we need to come the compaction effort is very low, and we can by have applying the minimum compaction effort, we can go by we can achieve the soil bearing capacity required, and we can go with smaller foundations, like smaller sizes of foundation, and just shallow foundation, which will reduce our cost budgets. But if the same amount, same structure, if I want to construct in black cotton soil, I need to I'm forced to choose deep foundation rather than the shallow foundations, just because it has high swelling and shrinkage capacity. That will allow the settlements, or it will gives you the settlements, sometime uneven settlements, which will lead to collapse of your structure or damages to your structure. So ultimate goal for us, reading this geotech or understanding the soils, is to find out uh, our structure is safe to construct or not. This is the whole concept. So finding out those soil bearing capacities, we need the properties first. So how we can judge the properties of soil? We need that we need to do by physical, and we need to understand the compositions or properties of that soil. So first we discuss how to find out whether the soil is clay or something kind of thing. So this if you see, our first topic is index properties and classification. We understand the properties of soil, and we classify the soils. Which one is it? Is it gravel, sand, silt, or clay? We differentiate that. So I hope, going moving forward, I hope most of you know how to make a roti, right? Anyone, please explain me how to make a roti.
Uh, First make dough out of the powder, like
Yeah.
uh, grind the sieve.
No, no, no. First, I you
We
came
have
to
to
me. I'm a
sieve the.
shopkeeper.
Okay, sir.
Perfect. Go on, Mohammed. Yeah.
Yeah, we have to sieve the grains like first before giving it to the sir. We have to sieve it. We have to differentiate between the categories of the soils. Like if you're talking about the
No,
soil,
no,
we
no. I'm
have
not
to.
talking of. No. I'm not talking about the soil. You came to me. I'm a shopkeeper. I gave you some ashirwad or some what we call wheat flour, and you just
Okay,
went to
sir.
the room to your house, and you find out there are some lumps and some kind of what we call sand particles or something like that
Stones.
Gradation.
in that
Yes, sir. We while
so
sieving we
Gradation.
what
can
We
you
have to do
what
the
you do,
we
gradation first.
yeah, okay.
while sieving we take different size we sieve it using different sizes. Like for
Okay.
atta, like for flour, we take different size and sieve it.
Hmm.
If we found any lumps
Okay.
or stones in it, we take out the stones from that part, and then
So
we. uh,
yeah, okay. From here, I'll continue, Mohammed. Thank you. So what we'll do, we'll buy that, we'll bought that wheat flour, and we take a sieve. If we find any lumps or something like that, we put that wheat flour in that sieve, and we just sieve that. And whatever the material which uh, like passed from that sieve is the flour which is absolutely no lumps or stones or sand, something like that. That wheat flour we can use for doing rotis. Okay. And whatever the retained part we have, those stones and lumps, we'll throw it out. And then we'll add some water. We add some water until this flour turns into plastic state. That whatever flour correctly comes in a situation where we can do a what we call roti or some that mold kind of thing. Okay. So same for the soil. Consider your wheat flour as a sand soil which you are taken from the field, and you just put into the sieve, and you do the sieve analysis. But in layman's condition, if you are making you are sieving the wheat flour, you just take one sieve that is available in market, which is you don't find any specific specifications or what is the sizes of sieves. You don't see. You just go to the market and you find the sieve which generally used for the sieving of flour. But in our condition as engineers, we need to quantify everything. We don't say uh, this is gravel. We need to mention what is the size it should be called, need to have to call as a gravel. We need to specify what is the sizes of the materials or the sizes of the grains it should have to call that as a sand. So this is how engineers quantify everything. We quantify everything to understand, to set some marks, some standards to identify which we need to use for which experiment or purpose. Okay. So same like that, we have in a soil we have four major constitutes like or types. Those are gravel, sands, silts, and clays. Those are grouped, or you can say gravel and sands are coarse soils, and silts and clays are fine soils. Okay. Why we call this as a fine and why we call as coarse soils? So whatever the materials which have higher like material higher grain size, we call it as coarser soils. Which are the materials have lesser grain size, we call it as finer soils. But as I said, as an engineers, we need to quantify everything. I just said the materials which the particles which having the higher what we call particles. That's not the correct statement. I need to we need to do. So the materials which is retaining on number 200 sieve is coarser coarser soils. The soils which is passing from number 200 sieve is known as fine soils. Okay, and we have gravel and sands as a coarser soils. We need to differentiate that also based upon the particle size, and we have silts and clays and fine soils. We need to classify that also, like silts and clays also. Okay, so coming to the coarser soils first, we just do the coarse like sieve analysis, and we'll whatever the percentage fineness passing from different sieve numbers, we plot those percentage finer based upon the grain size, based upon the size of the sieves, and we draw a graph. So based upon this graph, we'll find whether this soil is well graded or poorly graded or uniformly graded. Okay. So before moving into that, can anyone tell me what is number 10 sieve? Yeah, Khan.
Sand. Probably sand.
No. I'm asking these are the sizes of sieves. Okay. These are the sizes of sieves we use for sieve analysis. So in this thing, I know what is 4 inch, what is 3 inch, 2 inch. Okay. So on a random note, I'm asking what is number 10 sieve? What does it means? What is number 10 means? What it
So that has
specifies?
Particles of the
that
size.
that
There are 10
specify that
10
it
Yeah.
has
mm.
a two
Wait,
two
wait, wait, wait.
mm passing.
Okay.
Two.
So Sharif, go on.
Number 10 sieve has a the opening of 2 size opening in its mesh.
Okay.
No, it
You are saying
retains
about
2 mm. It
Number
retains
10 refers to the standard sieve size.
okay, Vishal. So let me give you a clarity. So number 10 is nothing but in a sieve, if you consider this is a number 10 sieve, if you cut anywhere in the sieve, if you cut 1 inch by 1 inch portion, 1 inch by 1 inch square, you will find 10 openings in minimum in it. So, okay. So you'll find 10 openings. Okay. That is number 10. If you cut that sieve 1 inch by 1 inch, you will find 50 openings, then it is number 50. If you find 100 openings, then it's number 100. But if you see from here, it is 4 inches, 3 inches, 2 inches. That means this opening is 4 inch opening, not like 4 inch, 4 inch, 4 inch, 4 inch. This diagonal is 4 inch. Okay. So that's how we differentiate the sieves also.
Sir,
So if anyone, this is not the question for FE, but this is question for your interviews. Okay.
sir, what about number 200? Like, if it's 200, if we cut
Yeah.
one in one by one, there will be 200
Yeah.
openings, sir.
Yeah.
Okay, sir.
Yeah. So we just gone through based on the finer percentage finer, we'll plot a graph, okay, against sieve sizes. So generally we have if you have the soil in your hand, like if you want to analyze those, better way to understand this is gravel. If you look into the gravel, um, a, uh, a truck which carries the gravel, it's generally have a bigger boulder and a smaller boulder and a smaller boulder, like this. It can fill the gaps between these boulders. Okay. So single size is nothing but if you using specific, like in India, if you want to lay some slab something, they use 20 gravel specifically for the slabs. So that 20 is nothing but single sized. If you take that load of or chunk of gravel in your hand, you will find 20 single sized gravel everywhere, like particles in that gravel everywhere, or stones in that lot. But if you come to well graded is nothing but it have all sizes. If you rate this one is the big boulder, which is like 40 mm, and you consider this small is the 5 mm. In between, whatever the sizes it may have, it have these all sizes will be present in this soil. That soil, that every other particle present in the soil is known as well graded soil. So if some of the particles was missing or in less substitutes or less percentages, then it is called poorly graded. Okay, poorly graded is also called as uniformly graded. Okay, and we in for FE we just want to know either uniformly graded or well graded or uniformly well graded or poorly graded. Sometimes you may encounter a word called uniformly graded. Uniformly graded is also known as poorly graded. Okay, and as we discussed, to find out, we have two types of soils. One is coarse grained soils and fine grained soils. For coarse grained soils, which is the soil which is retained on number 200 sieve, is known as coarse grained soils. To analyze these coarse grained soils, we use sieve analysis, which we are doing right now. And we have another set of soils, which is known as fine grained soils, which is not like passing from number 200 sieve, but we analyze it in different way. But you may encounter other question known as how you analyze these particle sizes, particles, grain size distribution, known as grain size distribution for fine grained soils. In that case, if the question is asked you about how you analyze or how you use or how you find out grain size distribution for fine grained soils, then it is hydrometer analysis. Okay, we don't look into deeper side and we don't do generally that hydrometer analysis until and unless it was a huge project. We want to know each and every thing exactly, then only we go for hydrometer analysis. Otherwise we don't do that. We just go by properties. Okay, which we are going to see in couple of coming slides. But hydrometer analysis is a experiment which is used to find the grain size distribution of fine grained soils. Okay, for coarse grained soils we use sieve analysis. So we have, if you see, this is well graded. If you see the well graded soils graph, it has every other from opening to having every other particle size in set of percentages. But coming to uniformly graded, you don't have these soils and you don't have these particle sized soil, but still it is uniformly graded, or you can call it as poorly graded. And you have another thing called gap graded. That means from like we talk 40 to 5 mm, in between these you have 40, you may have 5, but you may don't have 10 mm totally. So if you find from here to here you lost one set of particle sizes. Okay, this is known as gap graded. If some size of particles is missing in a soil, then it is known as gap graded. Okay, in between, if you have every other soil and have good proportions, then it is well graded. If you don't have few other character like particle sizes, you have only few of them, and it was like good constituents or good what we call percentages, then it is known as poorly graded. Okay, so based on this, we'll find Cu, coefficient of curvature, and coefficient of uniformity. Okay, these are the formulas for coefficient of uniformity and coefficient of curvature. Okay, so why we need to find out this coefficient of uniformity and coefficient of curvature? So this by understanding this coefficient of uniformity and coefficient of curvature, we understood how the particle sizes for given amount of percentage we are looking for. So at for 60% need to pass from sorry, in this soil, the 60% of the soil is passing from which sieve, or which number of sieve, or you can exactly want to say how much of opening is required to pass that 60% of the soil. So we'll find the shape indices. These are known as shape indices. We understood how the general shape of the particles was there or present in this soil. So to find out the CU and CC, we need D60 or D10 and D30. This is nothing but D is nothing but diameter in mm, and 60 is nothing but at 60% you, after sieving the thing, you'll plotting the graph, right? So in that graph, we take 60% final. At 60, we draw a line to the graph, and we draw an vertical line to the scale, log scale, which we are considering. Okay, so by taking this opening size, we understood this is D60. That means at this opening size, 60% of your soil is passing. Okay, so D10, D30, D60 we find out like same, and based on this we find out the indices. So why we need to find out the indices? After finding these indices, we can say whether it is well graded or poorly graded. Makes sense, right? So to say it well graded or poorly graded, we need to we need to quantify the thing to say whether it is poorly graded or well graded. So saying those is this soil is well graded or poorly graded, we set some quantity like numbers. So to find out those numbers, we use this CU and CC formulas. Okay, we'll go while solving the problems, you understand why what are the CU and CC and their limits. Okay. Okay, so up to now we discussed about coarse aggregates, sorry, coarse soils. What we have left remaining, we need to check fine soils. Just a minute, guys. Yeah, so up to the last slide we discussed about coarse soils. Okay, now we are going to see about fine soils. So there the 50% or more, if more than 50% is retained on 200, it's called as coarse soil. If 50% or more passed from number 200 sieve, you call it as fine soils. Okay, so finding out, to understand whether the soil is well graded or poorly graded, we come up with a thing called shape indices, which is known as DU and DC. But coming to the fine aggregates has different approach. Why? Coarse aggregate, if you take some gravel or sand, if you add some little bit of water and try to squeeze or mix those, they never really attach to each other. Why? Because coarse soils don't have cohesion to them, but for the fine soils they have a character called cohesion, which is nothing but attraction between two same particles. So there is an attraction between two particles, that is known as cohesion. So because of this cohesion, these soils have capacity to hold water. Okay, so based upon the holding characteristics of water, we come up with a limits called Atterberg limits. Okay, so in these Atterberg limits we have two things. One is plastic limit and another thing is liquid limit. Consider after sieving you have that fine sieved atta or wheat flour with you. So what we will do, you add little bit of water, you mix that, and you again add little bit of water, you mix that. So consider you take 1 kg of 1 kilogram of wheat flour and added just 100 ml of water to it. It was like it okay. Some portion of it will get like uh, converting into dough, but that is not a dough. Okay, so in that condition, it is known as semi-solid state. You have some kind of solids, but it have low what we call low cohesion. There is no pure all the particles was not attached to each other. Still some particles are left, and you keep on increasing the water quantity to it. What will happen? You'll at the you all the particles in that um, 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 bowl or some bowl is attached to each other, and it will make a pure dough. Okay, so this is plastic limit. In this plastic limit, you may roll your whatever the flour is attached to your hands. If you do like this, it will form thin threads. Okay, this threading experiment you may remember in doing in your laboratory while you are in bachelor's. Okay, you will do these threads with clay. So that threading is known as finding out the plastic limit thing. Okay. If you keep on increasing those, if you keep on increasing water to that dough, even if you achieve the plastic limit, what will happen? It started flowing. Like if you keep on increasing and mixing, it will turn into thick paste and it starts flowing. So whatever the point which the water start flowing or soil starts flowing is known as liquid limit. The point where you can make thin threads or the dough is known as plastic limit. Okay, so if you neglect liquid limit minus plastic limit, the water amount is known as plasticity index. Okay, so this is how we understand Atterberg limits. So in plastic state, every other particle is tightly attached to each other. So you have higher cohesion. And in liquid state, you don't have that shear capacity. In liquid state, there is no shear capacity to your soil. And yeah,
I have one
Vishal,
question.
Martha,
Yep.
yeah,
How
go
we
on.
measure the plastic limit and the liquid limit?
Yeah, we'll come into that.
Okay.
It's just if you take soil to soil and you just add some water to it and you start mixing that and start doing the threads. If that threads is coming at like if you added 10% of water and threads are coming, then that plastic limit for that soil is 10%. Okay, and you check prior values also like 9 8. If you add 9% of water and the threads are not coming, then your plastic limit is 10. Okay, and
Okay.
keep on increasing pouring the water, and where the all the particles is soluble in that soil or started flowing, then that case is known as liquid limit. But finding liquid limit, we use another mission, or we do another experiment called Casagrande apparatus. You may remember that one too. Okay, so by doing lot of experiments, we understood what is the plastic limit and liquid limit of that soil. But our job here is not to do the experiments. We analyze the results in FE. Okay. So that's why I'm not digging deep into the experiments. Okay. So up to now, we understood we have two types of soil. What are those? Coarse grained soils and fine grained soils, right? In these coarse grained soils, we have two, gravel and sands. We differentiate these things as well graded and poorly graded by using sieve analysis. So how we come a conclusion that what is what is coarse grained soils? If the materials retained more than 50% on number 200 sieve is known as coarse grained soils. The material if past 50% or more from number 200 sieve is fine grained soils. Okay, so we understood what is the limit for differentiate coarse grained and fine grained. So after that, to analyze the coarse grained soil, we use sieve analysis for the grain size distribution, and based on this coarse grained soil, we understood um, CU and CC with coefficient of uniformity and coefficient of curvature. Based on these, we understood either these are well graded or poorly graded. Okay. Next, coming to the fine grained soils, based upon the Atterberg limits, we differentiate whether it is low compressible soil or high compressible soil. Okay. Why the liquid limit or plastic limit is most important for the fine grained soils is fine grained soils have cohesion, and if that soil has capacity to hold the higher liquid limits, then it is high compressible. If you take the black cotton soil, generally if it is dry, there is no certain water, it looks good, it has least like what you call, it has definite set of volume. If the rain comes and rain that water squeezes into or absorbed by the black cotton soil, the volume increased by 1.5 times or 1.6 times, 60%, 70% also. Why? Because it has the capacity to hold the water within it up to 60% of its volume. That is liquid limit. Okay, so we differentiate this fine aggregate fine soils based upon the uh, water
Sir, can you
retaining
please
capacities,
repeat the
which is known as
differentiation
liquid.
between coarse grain soil and fine grain soil?
Sorry, may I know who am I talking to?
Zoheb, sir.
Yeah, Soheb. Yeah, go ahead.
So can you repeat the differentiation between coarse grain soil and fine grain soil? Thank you.
Yeah, the differentiation between coarse grain and fine grain soils is, if you take number 200 sieve, the soil 50% or more passing from the number 200 sieve, or in just a case, if the soil, whatever the soil is passing from number 200 sieve is known as fine grain soil. The soil which is retained on number 200 sieve is known as coarse grain soil. Okay, so have I clear?
2 or 200 पूछ लो.
Number 2, right, sir?
200.
For the coarse grain
Number
soil.
200. Number 200.
So number 200 is the last level of the sieve analysis, right? So you're telling, right, both coarse grain soil and fine grain soil both gonna pass us through this thing with the number
No,
200.
no. See, if you take 100 grams of soil, okay, you put it in sieve analysis, the soil which is retained on number 200 sieve, whether it may be retained on number 100 sieve or number 6 sieve or 5 sieve, it doesn't matter. Okay, whatever the soil which is retained above number 200 sieve is known as coarse grained soils. We'll again differentiate those based on the sieve analysis, whether it is what we call gravel or sand. Okay, but number 200 sieve is the sieve which differentiate coarse soils and fine soils. Okay, if soil retained in that 100 grams also, if 50 greater than 50 grams is retained, or 50% or more retained on number 200 sieve, then you call it as coarse grained soil. If the soil which is passing from number 200 sieve, you call it as fine grained soils. Okay, based upon the other approaches, we differentiate core, whether it is gravel or sand, whether it is well graded or poorly graded. Okay, whatever the soil passing from the number 200 sieve, you again differentiate using the water limits or liquid limits. You differentiate whether it is what we call silt or clay, which is high compressible or low compressible. Okay, so have are you clear?
Yeah, yes, sir. Yes, sir.
So particle
Thank you.
size having more retaining on number 200 sieve is coarse grained soil, passing from number 200 sieve is fine grained soils. Okay, these are all the things you need to you will you will encounter in coming sessions, like coming day, like slides. Gravel, sand are the coarse grain soils, silts, clay are the fine grain soils. You may encounter organic and peat in questions. It was like rare occasions. uh, if you find some statement saying in the question, saying that there is a organic content or plant waste or some kind of thing, then you may know that it is a organic soil or peat. It was like very rare condition. They don't are gonna ask you this what is organic and peat content. If at all you in the question, if they ask like there is some organic content or some plant content, you may pick any one of those. I don't think there two options will be in the question, either organic or peat. Okay, so you can pick from those. And coming to the differentiation, you may see well graded and poorly graded, low plastic and high plastic. Okay, so we understand how all these coarse grain soils and fine grain soils. Okay, now we're gonna differentiate this. Okay, so we know what we'll do first. We take number 200 sieve reading. If soil 50% or more retained on number 200 sieve, we call it as coarse grain soil. If number 50% or more passed from number 200 sieve, we call it as fine grain sieve. Okay. Um, for instance, we consider we took 100 grams of soil and we sieved. Okay. So in this 100 grams, 80 grams was retained on number 200 sieve. That means it is coarse grain soil. Okay, 20 grams was passed here. 20 grams was passed from number 200 sieve. Okay, next, in this 80 grams, 50 grams 50 grams was retained on number 4 sieve. We next see number 400, number 4 sieve. Okay, if number 4 sieve also 50 grams was retained on, out of this 80 grams 50 grams were retained in number 4 sieve, retained on number 4 sieve. So that means it is gravel. Okay, if 50% or more retained passed from number 4 sieve, then it is called sand. Okay, then what you will do, we need to find out whether we are looking for well graded, poorly graded, or dual symbols, or silt or clay. How we decide these things? We got 20% out of these. 20% are passed from number 400. So this, based on this passing percentage, we need to choose these things. Okay, if you are let me go to the, yeah, this one. If you see less than 5%, more than 12%. Okay, come here. So if less than 4%, sorry, less than 5%, yeah, less than 5%, you will choose these things, whether it is well graded or poorly graded. You just say gravel is well graded, gravel is poorly graded. Why? If you have less than 5% of fines in your soil, they don't alter the characteristics of that soil. It don't have the ability to induce cohesion in the soil, in the gravel. So that's why you see the passing percentages. Okay, so if it is greater than 12%, if it is greater than 12%, you need to mention that it is silty clay, sorry, silty gravel or clayey gravel. Okay, why? If it is more than 12%, this soil, this fine grain soils will induce some cohesion and alter the characteristics of this gravel. So that's why we'll let we tell that this soil has most of the this soil consists gravel, or this soil is very gravel, but it has some constitute of silt. Okay, this soil is gravel, but it has the percentages of clay. Okay, so because of this gravel soil properties may alter. Okay, and we talked about less than 5% and greater than 12%. What if it? What if my percentage is between 5 to 12? Then you have you need to say whether that gravel is well graded or poorly graded, and how that soil is, like whether the silt percentage is high or clay percentage is high. You need to say that also. Okay, so that's why we go for dual symbols. Same for sand. If this 50% or more passed from sand, you passed from number 4 sieve, you will understand that is sand. And you look into coefficient of curvature and cu and cc. CU and CC. Based on CU and CC, you'll find out whether it is well graded or poorly graded. If it is less than 5%, fines is less than 5%. And for here, you'll see LL and PL, liquid limit and plastic limit, if it is greater than 12% fines. Here you need to see CU, CC and everything if it is 5 to 12% of fines. Okay. Yeah, Mohammed. Yeah, go on.
Yes, sir. Sir, how do you categorize like you said 5 percentage? How you
Yeah.
make
So
it like how you know?
I categorize based on the USCS. Okay. This is the table you will see in your handbook too. Okay.
Yes, sir. No, sir.
We'll discuss it. Mhm.
Sir, what sieve number you took to categorize it 5%? How do you put
Okay. There
5%
is,
like?
yeah, okay, okay. So there is no see, like here he mentioned about less than 5% fines. Fines is nothing but fine grained soils. Okay. So if whatever the soil which is passing from number 200 sieve is known as fines. Okay. That's why I told you we took 80 grams of the soil. We took 80 grams, sorry, 100 grams of the soil. In this 100 grams, 80 grams is retained in number 200 sieve. So that itself saying it is coarse aggregate. So coarse grain soil. There is no confusion what soil it is. But 20% is passing from number 200 sieve, which will have significant what we significantly alter the properties of gravels or sands, or that coarse grained soils. So that's why we'll find out in this 20, based on this 20% is greater than 12%. So that's why we'll say whether it is gravel, silty gravel or clayey gravel. Okay. So this 20% is nothing but number 200 sieve, the percentage which is passing from number 200 sieve. Okay. This
Yes, sir.
5%, 5 to 12%, 12%. Did you got my point,
Yes.
Mohammed?
Thank you, sir.
So, okay. So next we'll find, we know if it is coarse grain soil, we understood how to find those things. But for fine grain soils, we have low compressibility, high compressibility. We already talked about what is low compressibility and what is high compressibility. Okay. If the soil holds a greater amount of water with it, it have more swelling and shrinkage nature. So if the soils which is lesser than 50% of its liquid limit, if the liquid limit of that soil is lesser than 40, lesser than 50, then it is low compressible, whether it low compressible clay or low compressible silt. Okay. If that soil liquid limit is greater than 50, then it is high compressible silt or high compressible clay. Okay. But here the problem is, if liquid limit is 50, we may get clay and silt. So we need to differentiate the clay and silts also. So different for differentiation of the clays and silts, we have a line called A line. This line is called A line. If we have equation for that, when we are doing our problems, you will understand better. So if your soil liquid your plastic, based on your plastic limit and liquid limit, you will draw a line. If this point is below liquid limit, this A line, then your soil is this one. Okay. If this point is above A line, your soil is clay. So if your soil falls above A line, it is clay. Below A line, it is silt. If your liquid limit is greater than 50, it is high compressible. It is lesser than 50, it is low compressible. Okay. This is how we differentiate fine grained soils also. So based upon these, you have USCS classification. Okay, this is the one classification you need to understand. You may expect one or two questions from this whole topic. And yeah, you may ask AASHTO classification too. AASHTO classification is nothing, always like, for whatever the tables you read in Geotech, just come from left to right. Okay, first you see number 200 sieve. Coming to right, you will see number 4 sieve. Coming to left, coming to left more, you'll see the lesser percentage fineness. Coming to the left, whatever the topics you need to look into, whether is you need to see a coefficient of uniformity, coefficient of curvature, or percentage fines like PI, plasticity index, whatever the things you need to look into, he given in here. And then coming to left, you'll come up with group symbol. Okay. So you, if lesser than 5%, well graded, poorly graded, greater than 12%, it is silty clay or gravel clay, silty gravel or silty sand or something, clay sand or clay gravel. You need to mention like that. And if you are between 5 to 12%, you will go for dual symbols. Okay. And next, coming to AASHTO classification, they'll give some values. You need to check from left to right. Whatever the character it satisfy the condition, you will come up with that A1, A2, A3, A2, 6 or something like that. So you will understand, if we done the problems, you will understand tomorrow doing the, we'll do around 8 to 9 problems tomorrow, so though you will understand better this AASHTO and USCS classification. Okay. Yeah. Anyone have any question?
So I want to
Chiranjeevi?
ask, uh, do you provide the questions like to practice after your class?
Um, like in class or after the
Uh,
class?
as a homework, sir?
Oh, okay, okay. So today no homework, and we'll discuss some problems tomorrow, so that you have some idea how to solve those questions. Really, you'll get good knowledge on tricks and tips how to solve those. And after that, if time permits, I'll discuss some index properties tomorrow, so that you will understand, so that I can have the scope to give some questions to you as a homework.
Okay, sir. Sorry.
Okay.
Okay, Madhav. Thank you very
Yeah,
much,
no,
Madhav.
So, Madhav, I
yeah,
have
no
one
problem.
doubt. Sure, sure, sure. So, in the
Yeah.
beginning of the class, I joined bit late. So,
Mhm.
I believe in the beginning of the class, I think you're saying something about like theoretical or numerical questions,
Okay.
like how many we can
Oh, yeah,
expect.
yeah.
Like,
Okay. So I just said that. I think you've seen the breakup, right?
no, no, I think
Which
I missed
breakup?
that part. I think I missed
Okay.
that part.
Yeah. So I said, you may expect this type of numbers. So for index property and soil classification, you may expect one or two questions, and phase relationships and laboratory and field test 2 to 3 questions, total and effective stress 1 or 2 questions. So this is the breakup of your marks typically these days. So, but if you see every other topic carrying a mark, Okay.
Yeah.
So even if you don't find one of those topic not like understand good, or you may feel this topic was not my strength, then also you can find you will score 9 marks from different other few topics also. So I hope if you find any difficulty in understanding any other topic, you can reach out to me and n number of times. And still, if you have some issue, or you finding it difficult, okay, let it be. Even though you may get other 9 marks from different topics, okay, and it is very much interlinked to any all other topics. In same way, it is very much distance from each other topic. Okay.
Okay.
um, some for deeper understanding, you need to understand each other topic as a subject whole. But for getting mark, you don't need to really that smart to understand everything. You just need to understand what is the formula, what is the question he asked, what we need to find out. Okay. And
Yeah.
second thing in geotech helps you is most of the questions, even if you don't have a good amount of knowledge or deeper understanding, by looking at the options, you if you use some smart things, some sort of like click, or I can say some simple common sense, you may end up understanding one or two options are not correct, which is not practically possible. So by eliminating those if you eliminate one option from it, probability of getting your correct answer is 33%. If you can eliminate two options from those, you probability of getting right answer is 50%. Okay. So make sure before start solving that question, see your options one or two times, so you may what we call eliminate few options by looking at those. Okay. So that's how geotech works. And geotech works in fe. So very much evident you may get good, like you may get good marks in this subject.
So, like, how much the
Okay.
weightage this subject carries? Like, how many
10
marks?
to 15 marks. 10 to
10 to
15
15.
marks.
Okay.
Most of the times you may get 11, 12 questions.
Oh, and
Yeah.
also you mentioned,
That
like,
means,
like showing some, like, the code book, like some data papers will be available for us. Like,
yeah, you handbook is available for you. And tomorrow, when we are solving the questions,
okay.
I'll refer those handbook numbers also, pages, and how you can find some tips and
Yeah.
tricks. You'll understand those tomorrow.
Yeah. Sounds good, Mother. Thank you. And definitely I'll
Yeah.
change my name, as you said.
Yeah.
Thank you
Thank
so
you.
much.
You're picking the weapons, right? And you are just learning. After attaining the all skills, you need to think about the strategy. Okay, first understand the subject so that you can prepare as per your strengths.
Yeah,
Share
go ahead.
my share my plan and everything on last class of Geotech.